We are looking at 8.4. So 8.2 and 8.3 were all about parallelograms. This one's about rhombuses, rectangles, and squares. All of those have what in common? They all have 4 sides. Good. A rhombus is a parallelogram, but it has 4 congruent sides. Okay. So that still means all the other rules that apply for a parallelogram apply to a rhombus, except rhombus has one more rule. It has congruent sides. A rectangle is a parallelogram, except it has 4 right angles. Okay, and a square is like a rhombus, and a rectangle had a little baby, and it was a square, so it has 4 congruent sides and 4 right angles. Okay, rhombus, corollary. A quadrilateral is a rhombus if and only if it has 4 congruent sides. Rectangle, corollary. Quadrilateral is a rectangle if and only if it has 4 right angles. A quadrilateral is a square if and only if it is both a rhombus and a rectangle, meaning 4 congruent sides and 4 right angles. 811, a parallelogram is a rhombus if and only if its diagonals are perpendicular. Okay, so its diagonals must cross at a 90-degree angle for it to be a rhombus. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So it cuts the angles in half. Can we draw a picture? Okay, so we've got a rhombus. We'll pretend all these sides are equal. Okay, then we've got its diagonals. The diagonals meet at a 90-degree angle. So all those are 90 degrees. And it cuts each of the angles in half. Okay? A parallelogram is a rectangle if and only if its diagonals are congruent. So for a rectangle, we know we've got 4 right sides. We know the opposite sides are congruent. And we know that the diagonals are congruent. Okay. All right. We are going to skip the proof. And we're going to move right around using properties of special parallelograms. Okay. For a rectangle, A, B, C, D. So when you hear about a rectangle and there's not one drawn for you, or a shape of any sort, I would draw it. A, B, C, D. We know we've got 4 right angles, right? We know the opposite sides are congruent to each other. Decide whether the statement is always, sometimes, or never true, and draw a sketch for our answer. All right, A says, angle A and angle C are congruent. Sometimes, always, never. Always. We know angle A and C are 90 degrees. Okay. What about AB to BC? AB and then B to C. Not never, sometimes. Why sometimes? Because a square is a special rectangle. Okay? If it's a square. Okay, let's think about this for a second. If I have a square, what are all the names I could call it? I could call it a rectangle. What else could I call it? All right. C. AC is congruent to BD. AC congruent to BD. Sometimes, always, or never. AC to BD. Always. Because what does it say right here? A parallelogram is a rectangle if and only if the diagonals are congruent. They do also bisect, but they are congruent. Okay. We're going to plot the following points. We've got A is negative 1, 4. B is negative 3, 2. C is 2, negative 3. And D is 4, negative 1. Okay. Is ABDC a rectangle, rhombus, square, or none of these? Justify your answers. Okay, so what are some things we have to know? Well, we know it has four sides, so we know it's a quadrilateral. It tells us it's a parallelogram, so I'm going to assume that's true. How would I prove that it was a rectangle? The angles would have to be what? Yes.
90 degrees.
And how would you prove angles were 90 degrees? You would prove that the sides were perpendicular. So we're going to figure out if AB is perpendicular to AD, and then we're going to figure out if DC is perpendicular to BC. And to figure out if they're perpendicular, we find the what? The slope. Okay, I'm going to do the slope without putting in the slope. I'm just going to walk over here and figure out that I go up 1, 2, over 2. So B to A is 1 over 1. Up 1 to the right 1. Okay, let's look at AD. I know from A I go down 1, 2, 3, 4, 5 over 1, 2, 3, 4. So I go down 4 over 5. Can this possibly be a rectangle? No. Okay. We know it can't be a rectangle because already we know they're not perpendicular to each other. Okay? So let's try this one. Yes. Did I do that wrong, Eric? Okay, so I'm going from A to D. So I go down 1, 2, 3, 4. Oh, 5 over 5. Thank you. So 5 over 5 reduces to -1. Is 1 perpendicular to -1? Yes, it is. Okay, let's look at DC and BC. D to C, C to D, I mean, we go up 1, 2 over 1. C is at 2, -3. So I go up 1, 2 over 1, 2 over 1. Okay. BC, I went down 1, 2, 3, 4, 5, 6. 5 over 1, 2, 3, 4, 5. We get -5 over 5. Can somebody check my DC for me? Another way to do it, I'm going to do the y2 minus y1 thing. -1 minus 3 over.
It's 2, 2, not 2, 1.
It's 2, 2? Thanks, guys. So -1 minus 3 over 4 minus 2. So I should get -4 over 4 minus 2 is 2. Me too. So this is x1, y1, x2, y2. Y2 is -1 minus a -3. This should be plus. It doesn't really help. Because -1 minus a -3.
No, because if you do
gives me
-1 plus 3,
2.
it's 2.
There we go. This work is not due arithmetic today. Okay, so I get 1 and -1. So first of all, I know it has 90-degree angles, which means it cannot be what? A rectangle, rhombus, or square. Can't be a rhombus because rhombus does not have 90-degree angles. So we're trying to prove if it's a rectangle or a square. So let's look at this. We could use the distance formula to figure out A to D and A to B. But right now, what if we're looking at it? Are they the same length? No. So it must be a rectangle. Why? It must be a rectangle because we have 4 90-degree angles. Not does not have an A in it. Not all sides are congruent.